Okay, so today's video is going to be a proof of the quadratic formula, and this is an extra video for people who would like to know where the quadratic formula comes from, how we get the quadratic formula. Okay, so we all know that the standard form of a quadratic equation is y equals ax squared plus bx plus c. Okay, now in order to do this proof, firstly we need to make it equal to 0, of course. So we're going to have 0 equals ax squared plus bx plus c. But what we're actually going to do first is we're going to remove the a. Okay, so we want that a to go away, okay, because what we would like to have is a coefficient of x squared that is 1. All right, so we want that coefficient to be 1. How do we do that? Well, we firstly divide everything by a. Now, in this case, we're going to actually divide each term by a here. Okay, just like so. All right, because we're actually going to use this as part of our proof. All right, so once we've done that, we now have 0 equals x squared plus b over ax plus c over a. All right, so this is our quadratic formula at the moment. Now, from here, we're going to use the technique that we've already learned throughout the last unit, and that was completing the square. Okay, so we're going to use completing the square to put this into vertex form and then solve. All right, so the first step that we usually do when we're completing the square is we try and find what we're going to add and subtract in order to solve this. So we do b over 2. Now in this case, b is actually b over a. Okay, so we have to take b over a and then divide that by 2. All right, now using our rules, we know that that's the same as b over a, and we can make this 2 over 1. All right, so when we are dividing fractions, we flip the second one. So we're going to change 2 over 1 into 1 over 2, and we change it to multiply. Okay, so we're actually getting b over 2a. Okay, so this is our term that we're going to add and subtract. So we have 0 is equal to x squared plus b over a x plus b over 2a squared minus b over 2a squared plus c over a. Okay, so we've added our extra terms. Now we can complete the square, or we can turn it into a square. So this part here is going to become 0 equals x plus b over 2a squared. Make that bracket a bit nicer. Apparently I won't, my eraser's not working. Minus. Okay, now at this point we can leave it like this, or we can start to simplify our squares. So we're going to do that. We're going to make this b squared divided by, and 2a squared becomes 4a squared plus c over a. All right, so we're on track now. We're getting closer with completing the square, but we now need to do some cleaning up. Okay, so we've done the important part now, but we need to clean this up because we want to turn it into a formula that we can use. All right, now at this point, what I would like to do is, firstly, we're going to move the x onto the left. Now, in this case, actually, what I will do is I'm going to subtract b squared over 4a squared, and I'm going to subtract minus b squared over 4a squared, so we're going to add that, and I'm going to subtract c over a, but because of how I would like my equation to look, I'm going to actually leave them on the right. Okay, so we're going to end up here with, whoops, don't know what just happened there. Okay, what we're going to end up here with is x plus b over 2a squared is equal to b squared over 4a squared minus c over a. Okay, so all we've done here is we've moved the b squared over 4a squared and the c over a to the other side, but I've also flipped it around just to keep the x on the left. Okay, so at this point, the main thing we need to do now is just tidy it up. Okay, once we've tidied it up, we can start isolating the x. Okay, so to tidy this up, we want to put these two fractions together. All right, in order to do that, the denominators must be the same. So what we're going to do is we're going to multiply the first one by nothing because a's in both of them. All right, we're going to multiply the second one by 4a over 4a. Okay, so we're going to multiply the numerator and the denominator by 4a. So we now have the same thing on the top. X plus b over 2a squared is equal to b squared over 4a squared minus 4ac over 4a squared. Okay, so that's lovely. Now we can put them together. So x plus b over 2a squared is equal to b squared minus 4ac over 4a squared. And those of you who have been paying attention in the previous lesson would recognize that b squared minus 4ac, that is our discriminant. Okay, and now we can go a little bit further. So this is now simplified. In order to isolate the x, the next step is that we take the square root of both sides. So we're going to have x plus b over 2a is equal to the square root of b squared minus 4ac over 4a squared. Okay, and we also get the negative. Okay, so x plus b over 2a is equal to the negative square root of b squared minus 4ac over 4a squared. Okay, now at this point, what we need to do is we need to look at what we can do with this square root, because we can actually tidy that up a little bit. Okay, so we're going to tidy that up before we make any more steps here. So we've got x plus b over 2a. I don't want to touch that at the moment. Now, the numerator we can't change. B squared minus 4ac, we cannot take the square root of that. Okay, you cannot do the square root of b squared and write b minus the square root of 4ac. That does not work. Okay, that's not correct maths, and I'm not going to go into why at this point, but if you think about your expansion of brackets, okay, and your perfect squares, then you would realize that that doesn't work. All right, so on the top we're going to keep it as it is. So we're going to leave the top as the square root of b squared minus 4ac. Okay, and the bottom we can actually take the square root of. So the square root of 4 is 2, and the square root of a squared is a. All right, and the same on the other side. So x plus b over 2a equals negative root b squared minus 4ac over 2a. Okay, we're almost done. And you should be able to see what we're going to do now. We just want x by itself. So we're going to subtract the b over 2a. So what we end up with is x is equal to negative b over 2a plus the square root of b squared minus 4ac over 2a, or x is negative b over 2a minus the square root of b squared minus 4ac over 2a. Now at this point you can see that the denominators are the same for both parts of your fraction, so we can combine them. So x equals negative b plus the square root of b squared minus 4ac, whoops, it's a terrible line, over 2a, or x equals negative b minus the square root of b squared minus 4ac over 2a. Okay, and here, yeah, we're basically done. You know that the discriminant d is b squared minus 4ac. So if you would like to write it now in the shorter way, we say negative b plus the square root of d over 2a, or x is negative b minus the square root of d over 2a. And there we have it, our quadratic formula. And so we've just gone through a proof of how it works, how we get that quadratic formula using just ax squared plus bx plus c. Okay, so this is not something I expect people to memorize, or it's a good idea to be able to describe where this came from. Okay, we got this by using the standard formula and completing the square. Okay, you definitely are not expected to be able to do this at this point, but for people who are likely to do Wiskunde B in the future, it's really good that you have a bit of a grasp of this so that you can see what kind of proofs may come up in the future, especially if you're likely to do Wiskunde D. But it's basically just, we like to show you the proofs so that you have an idea of where things originally come from. Okay?